Hello and thank you for coming to check out this video. Today I'll be talking about how to understand troubleshooting audio quality issues. The first thing you want to do is define the problem, and in order to do that you have to ask as many questions as you can think of, and then take a moment to think of some more questions and start asking those. One of the questions here probably seems a little bit off, and that's whether or not the carpets have been replaced. The reason I put it up there is because there's been about 5 times or so where I was troubleshooting audio quality issues, and in the end it turned out that they had the carpets replaced. Well, when the carpets are replaced, what they do is they take all of the desks and phones and computers and everything else, move it out of the room, they cut up the old carpet and they lay down the new carpet. Then they move all the desks and phones and computers back in, they cable it up. In the scenarios that I've had in the past, they cabled it up wrong, so there was a handful of people that had audio quality issues, either one-way audio, no-way audio, things like that. And it turned out to be that their phone, their headset, their handset was just cabled up wrong. And one of the easy ways that I identified that the cabling was wrong was I asked them to test on speakerphone. And when they were on speakerphone, there was no audio quality issues. And with that one question, we were able to narrow it down to being either the handset or the headset, and things moved forward pretty quickly with that. So as you can see, it can be very important to ask the right questions. One of the other very important questions here is getting a topology. The topology lets us see how things are set up. And that's very important because later on when we're going to look at signaling and media, we need to understand who's who, what's going to go where, what's connected to what. And in talking about the signaling and media, one of the important things is the exchange of the IP and port, which we can see the IP and port for phone A here, and we can see the IP and port of phone B here. When phone A and phone B make a phone call, which in this scenario phone A is going to call phone A will establish a connection with CUCM. That connection will be for phone A to say, hey, I want to call phone B, can you help facilitate that? In order to do it, CUCM needs to know the IP and port of phone A. So phone A will send it over to CUCM, and then CUCM will open up a connection to phone B. It's basically saying, hey, you have a phone coming, go ahead and start ringing. Eventually, the person at phone B will answer the call, and phone B will send its IP and port back to CUCM. CUCM will then, having exchanged the 2 different IPs and ports between the 2 different phones, will allow them to open up a media connection between each other, where the RTP will be streaming directly. In this scenario, it's streaming directly. There's no media resources or anything of that nature. And then eventually somebody will hang up, and the signaling will be torn down. Along with that, the media will be torn down as well, and the call will be no longer existent. So now that we understand the difference between how the signaling gets from point A to point B, and we also understand that media does not follow the same path always, then we can start looking at an example call here where, let's say the signaling's already out of the way, the call's connected, and these 2 people are talking to each other. In this particular scenario, let's say that phone A can hear phone B, however phone B cannot hear phone A. What we'll want to do is get a packet capture at phone A to make sure that phone A is actually sending its packets. And if it is sending the packets, we want to make sure that they're not empty, that the RTP payload is there. What if we got that PCAP and we analyzed it and saw that phone A is doing everything it's supposed to be doing? Well, we might as well go ahead and get a PCAP at phone B as well then. Before doing anything else, just get the PCAP at phone A and get the PCAP at phone B right out of the gate. And it's possible that phone B will be receiving the packets. If phone B is receiving the packets, we could check to see its audio statistics, its streaming statistics, which is something I'll talk about later, to make sure that phone B isn't dropping it due to a packetization issue or anything like that, packetization rate, which is also called P time. So let's imagine that phone B is not receiving the packets, but phone A is sending it. We'd want to get PCAPs at the ingress interface on the different devices within the path. That would lead us to start with the switch, but if we're going to do that, we might as well get it at the other devices that are in the path as well. Now, what if these devices on the ingress interface are receiving it, or maybe even just one of them received it, but the next one didn't? Because of that, we'd want to get PCAPs on the egress interface of these devices as well, to make sure that not only did it receive it, but it sent it. If you're like me, you're looking at the different points on the slide and thinking that is a lot of work. That's a lot of different points where we would have to get packet captures. So really, to cut down on the amount of work but still have a very good level of effectiveness, we'd only want to get packet captures at the phone that should be transmitting. We want to get packet captures at the egress for the site where that phone is. Then we'd want to get packet captures at the ingress for the next site, and then also at the phone which should be receiving it. If we get these types of packet captures right out of the gate, we segment where the issue can be. It's going to be in site A, the internal network, or it's going to be in site B. If we don't see any packets on the egress interface of router A, well then we know that the issue is going to be either on router A, right, because maybe the packets came into router A and router A did nothing with it, or it's going to be, more upstream in the switch or at the phone or wherever it might be. However, let's say we did see router A sending the packets out. Well, then either the issue is going to be in the internal network or at site B. So then we would jump over to site B and see if the packets came on the ingress interface. If they didn't, well then router A sent the packets, router B didn't get it, the issue is going to be in the internal network. If router B did receive it, but the phone B did not, well then the issue is going to either be that router B did not send the packets, or the issue is going to be on the switch or some cabling or something like that at site B, therefore allowing us to narrow our troubleshooting down to site B. Now let's imagine a scenario where we have a phone call going to the service provider through our cube, and in this scenario we have a flow-through call flow, which means that the media is going to go from the phone to the cube, and then from the cube to the service provider. In this scenario, where do you think we'd want to do packet captures? For me, I'd want to do packet captures on the phone, but I'd also want to do packet captures on the egress interface of the cube. This would allow us to check the quality of the audio at the phone, but also at the point of departure for our cube, where it's our network, where it's our responsibility, versus where it's the service provider's responsibility. And if everything is clean on the cube's interface that interfaces with the service provider, then we can go to the service provider and say, hey, we have packet captures where the audio is clean. We believe that there's something going on in your network, and then you can involve them to help in the troubleshooting efforts. Before you can do the packet captures on the phone, there are some configurations that need to be done. So let's go ahead and enable web access on the phone, and then we'll also enable span to PC port. Once web access is enabled on the phone, we should be able to browse to the phone's IP address and take a look at its web interface. And then if we go under network setup, we can find the point where it says span to PC port and see if that says no or yes. For our scenario, we want it to say yes because that's what's going to allow us to get a packet capture from the phone. So here's why we would want that to say yes, because when it says no, as you can see here, traffic that's destined to the PC, the phone will take it and pass it through to the PC, as you can see by the line that's kind of highlighted in yellow. The other line, which is traffic destined to the phone, does not go to the PC. With span to PC port set to yes, the traffic will actually go from the phone and be passed through to the PC, therefore allowing us to use Wireshark, which is installed on this PC, to do the PCAP, to do the network capture, and then we can save it to a file for analysis later. With an understanding of how to get the phone packet capture, let's also talk about how to easily identify the media path. On the phone page, if you go to Stream 1, you'll be on the Streaming Statistics page. While on the Streaming Statistics page, you can look at the local IP address and port. That's going to tell us what the phone is using in terms of IP and port to receive media. But we can also look at the remote address, which tells us the remote IP address and port, letting us know what the far end is using for receiving media. This is very important for when we go to determine where we're going to make our packet captures. In this scenario, you can see that phone B is the remote address, letting us know that the media goes directly from phone A to phone B. If there was a different IP address here, then we would know that there's probably a transcoder or an MTP or a conference resource or something that is in the middle between phone A and phone B. At this point, we now understand how to think through where to get packet captures, what questions to ask, We also know how to enable the phone to span to the PC port so that we can capture the phone's traffic in a packet capture on the PC. And we also understand how to quickly identify the media path using the phone's web page looking at streaming statistics. Now, I recently did a video on Wireshark, which I'll put up here at the top of the screen. If you want to understand how to analyze the packet captures, please go ahead and check out that video. I show how to install Wireshark, how to get sample packet capture so you don't have to recreate issues yourself. The resources are already out there available for you on the Wireshark wiki. And then I also show how to create filters to really narrow down what's on the screen and whittle away at it so that you're only looking at what you want to look at. I hope that there was some value in this video for you, and I'll see you in the next one.